This is a quick review of right triangle trigonometry ratios. We start with a right triangle, and I've labeled one of the acute angles with a theta. The hypotenuse is always going to be the side opposite the 90-degree angle, but I want to label the other sides relative to this angle theta. So the side opposite theta is over here, and the adjacent side is right next to and touching where the angle lives. And based on these three sides, I can build different ratios comparing two sides at a time. The ancient Greeks were very smart in that they understood triangle similarity, and they knew that right triangles that had the same angle measures were similar. And that meant that all their sides are going to be in proportion. So basically, if you knew the angle measures of a right triangle, you really did know how to find the side lengths if you at least had one of the sides. And also, if you knew the side lengths, at least two of them, you would be able to find the angle measure. Now, I'll have other videos on how to do that, but this video concentrates on how do you actually build these ratios. So we're going to look at how many different ways we compare two of the sides. So the first ratio we can build is called sine. These are named by the Greeks, so these are Greek words. And sine compares the opposite side to the hypotenuse. And sine, which we abbreviate to three letters sin, sine theta, is opposite over hypotenuse. The second ratio is called cosine. Cosine will compare adjacent over hypotenuse, and we'll abbreviate that as cos. Cosine theta is adjacent over hypotenuse. The last ratio we're going to look at here is called tangent. Tangent is going to compare the opposite side over the adjacent side. We abbreviate that tan. Tan theta is opposite over adjacent. There actually are three other ratios that we can come up with by taking the reciprocals, but we're not going to do that here. We're just going to use these three because that'll do everything we need. These are actually kind of hard to remember. So how am I going to remember that these are the different ratios and these are their funny names and how this all works? So somewhere long ago, I'm not sure who or when this happened, but somebody said, why don't we use a mnemonic aid? And a mnemonic aid uses the first letters of different words to help us remember things. So somebody thought about it and said, hey, look, sine starts with S, and that's opposite over hypotenuse, and those start with O and H. Cosine starts with C, adjacent over hypotenuse, that's A and H. And tangent, that starts with T, and there's an opposite over adjacent O over A. We could put all these letters together, and you know what you get? SOHCAHTOA. And SOHCAHTOA are the three most important nonsense words that any geometry student should remember because it's going to help you know what the different ratios are. Let's look at an example. So here is a right triangle. I see where my theta is, so I want to label my sides. Hypotenuse is always going to be opposite the 90, but the side opposite theta is the 3, and the adjacent side is the 4. So if I want to find the sine, the cosine, and tangent of theta, I'm going to build the different ratios. Now, sine is opposite over hypotenuse. So let's see. Here my opposite is 3, my hypotenuse is 5. So sine of theta will be 3 over 5, opposite over hypotenuse, which is 0.6 if we wrote it as a decimal. Cosine is adjacent over hypotenuse. In this little figure here, my adjacent is 4, my hypotenuse is 5. So cosine theta is 4 over 5, or 0.8 as a decimal. Tangent is opposite over adjacent. In this case, opposite is 3, adjacent is 4. So tangent of theta is 3 over 4, or 0.75. What if I wanted to find the ratios for the other acute angle? So theta is one of them. Let's call the other angle alpha. And so I have to adjust my labeling. So while my hypotenuse is still going to be 5, the 4 and the 3, the 4 is the opposite relative to alpha, and 3 is the adjacent. So if I want to find sine, cosine, and tangent of alpha, I'm still going to use SOHCAHTOA. Sine is still opposite over hypotenuse, but now my opposite is 4. Hypotenuse is still 5, so my sine of alpha is 4 over 5. Cosine is still adjacent over hypotenuse, so that's 3 over 5 now. And tangent is still opposite over adjacent, but now my opposite over adjacent is 4 over 3. So you have to be very careful to label those sides correctly. But if you can do that, just remember SOHCAHTOA. To find these trig ratios, first label the sides, hypotenuse always opposite the 90, and then be careful opposite and adjacent relative to the acute angle you're interested in, and then just use SOHCAHTOA. I hope this was helpful to you, and as always, thank you for watching.